Regards, my name is Sebastian Romero Laguna, and today I would like to present the project I have developed as an IoT system. Let's start here. This project aims to connect different soil moisture and environmental air quality sensors located in both Brisbane and Melbourne. The idea is to debug in every process using Node-RED and then use functions that that use modern JavaScript code in order to separate different fields and tags, which then allow us to send a payload and this data, which is filtering the most important fields in the metadata that is sent from these sensors using MQTT, then are going to end up here in InfluxDB. We use several other modules to catch any issue that may find in a book, and then we send it. In case anything pops up, we can clearly see it either in here or in the console. All of them uses the same thing, and we use the same um, InfluxDB out for all the for both Melbourne and Brisbane. Instead of dividing it, we can just use the same function and the same node for the database. This because the data is exactly the same with minimal variations that we can through code in experimentation we can just clean and ensure that the data is what we expect. Then in here, we can play with the data. When we run it, we can clearly see that something is coming, and we can even see, you can even visualize it in here in a graph. There are different tools that allow us to do this, and then to filter according to sensors. Let's say I am only going to bring Melbourne data. Then it's going to bring only data from Melbourne. This is because we are using tags and not only fields, which is the basic thing taught during the course. But digging deeper was a clear a critical part of this project due to InfluxDB is huge and there are many features that it required time to cover. And it's actually something that I spent a long time, like days, literally like 2 to 3 days trying to figure out how to work with this and how to do it properly. After this, not to say that I know it well, but I have experimented with it enough so that we can come and create graphs like this. Here we use Grafana, which basically uses different queries to influence TV. In this case, as we can see, we're using the location, so we can say Melbourne, but then we can choose Brisbane, and the data may change. Well, there is no data for Brisbane in this moment, but surely maybe for another one. This is the beauty of this dashboard that you can personalize it as much as you need. Let's say we're showing the data for Melbourne, but what if we pick Brisbane? Then the data may change, right? Because it's a dynamic dashboard. Um, it's not just a static dashboard. And this is achieved by using the tags that we talk in here. We're talking about tag keys. This is similar to an index key in normal SQL, but this is not the case. But we can compare it that way, so we can understand what it is. And and once we're here, we can do multiple things. Like we can filter by location, but also we can filter by device. It is important to say that this was achieved by um, going to the variables, which then contain query that get all the data that is in the tag location, which was personalized in here. Due to we only have two locations, it's easy to create a simple if condition that says if contains B and E, it's Brisbane, otherwise it's just Melbourne. That way we can add a location field. Well, in this case, it will be more accurate to say a location tag. And this is cool because we can personalize dashboard and see things in real time. I would like to also share with you this screenshot that will allow you to see it in higher definition. Along with this screenshot, which is the diagram, the system diagram, the architecture. We have the CQU campuses. We got two campuses, and then we have different environmental air quality sensor or soil moisture sensors, which connect to LoRa gateway, which are in the case of Brisbane in the IoT lab, and then they go through either Wi-Fi or Ethernet in case it's directly connected to it through a platform called SerpStack, which is a LoRaWAN network and application server. It is hosted by the university in the port 8080 of Node-RED CQ EDU AU. I believe it is hosted in an AWS EC2 instance, as mentioned by the professor Dr. Biglop. And then it goes through an MQTT broker. Then we subscribe through to it via event and username and password as a insurance data security. Then we go and send it to here to data to Influx DB, and then it goes to Grafana, and then we can access it via uh, just a normal browser. So it is great. It is cool. It is good to see how things can change so much and go from nothing from raw data into this into useful data that will present us some insights. In this case, how useful is it to see the temperature of each one of the rooms in each one of the sensors across CQU. And it is also useful to filter because we're seeing only Melbourne, and then we can also see Brisbane. So in this way, we can ensure that the labs are in the ideal conditions in the different environments are suitable for students to go and learn, and also for different devices. And we can go and dig much deeper into it and see the moisture, the air pressure, and different others. Also, the battery by device over time. This is especially important because sometimes these devices may run out of battery. So it is very good for us to have a way to measure how is the battery of the device over time, how it is changing. For some reason, this here it was full and then it decreased and then increased and then coming back. This may be a battery change. We don't know, but it's good to have this data. And that is all for today. Thank you very much, Professor Biblop. I have learned so much, and I am glad to present this project after a lot of effort. Thank you very much also for your guidance.